You know that feeling when you're looking at a big block of Java code, maybe an anonymous inner class, and you just think, there has to be a better way to write this? Well, if that's you, then you're in the right place. Today, we're going to dive into Lambda expressions. They're this awesome Java feature that lets you take all that clunky, verbose code and turn it into something super clean and easy to read.
Okay, check this out. This one slide really tells the whole story. On the left, you've got the before, the old way of doing things. It's a lot, right? Kind of clunky, works, but it's just so much code. And then on the right, that's the after. That's what you get with a Lambda expression. A single, elegant, straight line. That's the journey we're going on today, from cluttered to concise.
So the million-dollar question is, how in the world do we get from that big clunky thing on the left to that super clean one-liner on the right? It's not magic, I promise. It's all about understanding that the Java compiler is actually really smart. It can figure out a lot of what we mean, which lets us chop away all the boilerplate and just focus on what we actually want to do.
So here's our game plan. First, we'll take a quick look at the old way, so we know what we're dealing with. Then comes the fun part, the makeover, where we'll go step by step. After that, we'll nail down the Lambda syntax rules. And finally, we'll talk about the payoff, why you should even care about all this. All right, let's get into it. Section 1, the old way. To really appreciate how awesome Lambdas are, we first got to understand the problem they solve. And it all starts with this concept called a functional interface. Okay, this is super important, so listen up. Lambdas have one big rule. They only work with a functional interface. So what's a functional interface? It's just a fancy name for an interface that has exactly one abstract method. Not 0, not 2, just 1. This one rule is the key to everything we're about to do, so lock it in. So throughout this whole explainer, we're going to use a really simple example. Here's our functional interface. We'll just call it A. And look, it's got just one abstract method inside called show. See, it follows the rule. That makes it the perfect candidate to show you how this whole Lambda transformation works. Okay, now for the main event, the makeover. We're going to take that clunky, old-school anonymous inner class and, step by step, we're going to carve it down into a beautiful, concise Lambda expression. Let's do this. Okay, step 1. This is our starting point, the full-blown traditional anonymous inner class. See all that extra text? The new A, the public void show? That's what we call boilerplate. It's just noise, really. And here's the secret. The compiler is smart enough to know all this stuff already. It knows the type is A, and since A is a functional interface, it knows there's only one method we could possibly be talking about. All that extra typing is totally redundant. All right, on to step 2. Time to start cutting. The first thing to go is the class definition part, that new A stuff. Why? Because the compiler isn't dumb. It sees the variable is of type A, so it already knows what's up. We don't need to spell it out. So, chop. It's gone. Next up, step 3. The next piece of boilerplate we can get rid of is the whole method's signature, public void show. Again, think about it. We're working with a functional interface. It only has one method, so the compiler knows exactly which method we're implementing. The name is just extra clutter. All we care about are the parentheses because that's where the parameters go. And now for step 4. This is the moment it actually becomes a Lambda. We add the arrow. It's just a dash and a greater than sign. But this little arrow is the heart and soul of a Lambda expression. It's a simple little symbol that basically says, hey, take the parameters on the left and use them to do the stuff on the right. It's the separator between your inputs and your action. Finally, step 5. And this is the most satisfying part for sure. If your implementation is just a single line of code, you get a bonus simplification. You can ditch the curly braces and the semicolon. The whole thing just snaps together onto one clean line. And there you have it. We went from that big, chunky block of code to this single, beautiful, readable line. Pretty cool, right? Okay, so we've seen how it works with a simple example. But now let's get a little more formal and look at the actual syntax rules. This will help you know exactly what to do in different situations, especially when you start dealing with parameters. This table lays it all out really nicely. So if you have 0 parameters, you just use empty parentheses. Easy enough. If you have a bunch of parameters, you just list them out, separated by commas, inside the parentheses. But the really cool one is when you have exactly one parameter. In that special case, you can drop the type, the compiler figures it out, and you can even get rid of the parentheses altogether. It makes the code super, super clean. So let's just quickly recap those key simplification rules. Rule 1,
Don't bother writing the parameter types. The compiler is smart. It'll infer them. Rule 2, if you have just one parameter, you can drop the parentheses around it. And Rule 3, if you have just one statement in your code block, you can drop the curly braces. If you can remember these 3 things, your Lambda expressions are going to look amazing.
So we've covered the how pretty well, but now let's talk about the why. I mean, why should you even bother learning this stuff? What's the real payoff here? Because trust me, it's way more than just making your code look fancy. Well, the biggest and most obvious win is this. We went from 5 lines of code down to just 1. That's a huge reduction. It means less typing for you, less code for someone else to read, and way less to maintain down the road. You get to stop worrying about all that ceremony and just focus on the one line that actually does something. Now, here's a benefit that's a little more under the hood, but it's really important. Back in the day, when you made an anonymous inner class, the compiler would actually create a whole separate .class file for it. You'd end up with all these extra files cluttering up your project. Lambdas? They don't do that. They use a more modern approach so you don't get all those extra files. It just keeps your whole project build cleaner and simpler. So, let's wrap it up. The payoff is pretty clear, right? 1, you write way less code so you can focus on the important stuff. 2, your code becomes a lot more readable, which is a massive deal, especially when you get into more advanced things like the Streams API. And 3, you get a cleaner project without a bunch of extra files. These are the reasons why you pretty much have to know Lambdas to be a modern Java developer. Okay, so we've totally nailed how to use Lambdas for methods that just do something, like printing a message. But that leaves a pretty big question hanging, doesn't it? What if your method needs to return a value? How does that change things? What does the syntax look like then? Well, that's the perfect next step on your journey to mastering Lambdas.